efficiency. Today we're going to talk about efficiency and how to do some simple calculations with efficiency. Now in physics, efficiency is defined as the ratio of useful work out divided by work input. Now, since work and energy are the same thing, we can also define this as energy out divided by the energy in, and since power is simply energy divided by time, or work divided by time, we can also define it as power out divided by power in. Okay, so as an equation, we can write it this way. Efficiency, I'll put a period in there, is equal to work out divided by work in, which is also equal to energy out divided by energy in. Now if you leave it like this, you're going to get a decimal answer. So if you multiply this by 100, you'll get your answer in a percent, like 30% or 50%, whatever percent into here. Okay, so this represents the equation that we're going to use to do calculations with efficiency on here. You could also use power here out divided by power in into here. Okay, now since it's a ratio of two equivalent things, efficiency does not have any units whatsoever onto here. Okay, so let's do a relatively simple problem doing or using this equation into here. One that's a very common problem into here. So here it goes, problem number 1. Okay, let's say that we have a 7.5 horsepower motor pulley system, and it's going to be used to raise a 1200 kilogram steel beam to a height of 15 meters in a time of 45 seconds. And the question is, what is the efficiency? Okay, now in order to solve this problem, right, oops, made too much of it disappear. In order to solve this problem, what we need to do is bring our equation, okay, and the equation will be efficiency, right, it's going to be work that we get out divided by work that we get in. So the problem here, I have to multiply that by 100. The problem in here is to understand what is the work out and what is the work in into here. Okay, so take a look what you're doing. You're taking a steel beam. Yeah, here's a picture of a piece of steel beam like this. Here you go. It's an I-beam like this. Okay, and there it is like that, and we're going to take this up like this, and there's the beam that's going up like this. Okay, and we're going to lift this beam up to a certain height onto here. Now the work that we do out is going to be equal to force times distance, which will be the force we have to use to move this beam up to a certain height onto here. Okay, now the force here will be the force of gravity. And we can calculate that by taking the 1200 kilograms and multiplying it by 9.81. That'll be the force. Then we multiply that by the distance. And this together into here will be the work out. So the work out will be equal to 1200 times 9.81. Move this over a little bit. Times a height of 15 meters. Now if you work this out, I have done this already for you, you're going to get, I believe, 176,580 joules of work putting it out. That's the useful work get out. Now the work in, a little bit different. We need to use the motor. So now it's a 7.5 horsepower motor, and the work that we're going to have here is going to be equal to power times the time. Now the power here will be 7.5 horsepower, and we're going to multiply that by 746 watts per horsepower. That's so that we can get this into watts, and then we're going to multiply by the time, which is 45 seconds. So if you multiply that out, you will get 251,775 joules of work that we had to put into the system to make it happen. So that means then the efficiency of this system will be as follows. All right, get this up in here. The efficiency then will be equal to, okay, there it is, the work out, which is 17658 joules, divided by the work in, 251,775 joules, and then we multiply that by 100 to get into a percent. If you work this out, I believe that you will come out to be 70% efficient on this system here. Okay? All right, so I'm going to give you one more problem to try and do. Have a look at it. See if you can solve it. Okay? After I give you the problem, pause the video, see if you can work it out, and then check your answers out into here. Okay? So here it is, problem number 2. And let me give you some space here. There we go. Problem number 2 says, how much time would a 4.5 horsepower motor take in increasing the speed of 115 kilogram go-kart from 0 to 9.3 meters per second at an efficiency of 32%. Okay, so at this point, pause the video, work it out, then check the answers afterwards. Have the answer? Well, let me show you how to do it. Okay. In this case, again, this skips too high. In this case, efficiency, I'm get the right one in here. Efficiency is going to be equal to energy out divided by energy in, and we're going to multiply that by 100%. So energy out, well, remember, we have the efficiency, 32%. We know that's going to be 0.32. The energy out, let me switch colors here. Energy out is going to be the change in energy kinetic of the cart, which means it's going to be equal to the energy kinetic 2 minus energy kinetic 1, 1/2 times mass times v squared minus 0, because it says it starts from 0. So this will be equal to 1/2 times 115 times velocity of 9.3 squared. If you work this out, you will get 4,973 joules to make it in. Okay, that's how much energy we get out. The energy that we had to put in to make this happen is going to be equal to power times time. And the power we have is 4.5 horsepower, again, times 746 watts per horsepower. And then the time, we don't know what the time is. We're going to actually find what that time is into here. Okay, so that'll be the unknown. So our equation now will look like this. Efficiency would be 0.32 from that. That's going to equal 4973 joules on top here. On the bottom here will be the number of 4.5 times 746, and that will be 3357 times the time, and that's what we're going to find out right into here. So a little rearranging, time then will equal 4973 divided by 3357 times 0.32, and that's going to be 4973 divided by 1074, which in fact equals to 4.6 seconds. All done. I hope you got that answer. Now go back to the worksheet, finish off the worksheet, and see what you can do.